Okay, in a previous video, I introduced little g and how we need to be more careful and used it to introduce the universal law of gravity. So this is a gravitational force between any two objects. Now, what we've been doing is we've been saying F is equal to mg, little g. And it was a vector and it pointed down, okay? And g was 9.8. Well, where did that come from? Well, the idea is that these are the same. This is just applying the universal law of gravity to objects on the surface of the Earth. Okay, so if that's equal to this, and we'll just take magnitudes right now, so forget the directions and the attractive negative sign. We get g, and I'm going to put m of the Earth times the mass of whatever is being acted on. Again, this could be me being pulled by the Earth. This is me being pulled by the Earth. Okay, and divided by, well, I'm standing on the surface of the Earth, which means the distance between me and the Earth is not 0, but the radius of the Earth, because this is measured from the centers of the objects, not the surfaces, but the centers of the objects. So this would become RE squared. I'm standing on the surface of the Earth, and it's the Earth I'm standing on. So now I look at this and say, okay, well, what's the same here? Well, my mass is the same in both, and what's left over are these numbers, which are constant if I'm standing on the surface of the Earth and measuring what the Earth is doing to me. So this is now g sub e, meaning the gravitational acceleration caused by the Earth when an object is at the surface of the Earth. That's where I get this whole subscript. Now, you don't need to write that whole subscript, but you need to know that that's what that means. Okay, so let's take an example. What if I'm not at the surface of the Earth? What if I'm at the moon? Okay, what if I'm near the surface of the moon, but I'm being pulled by the Earth? Or better yet, how is the moon feeling the gravitational pull of the Earth? Okay, so that is going to be m moon times g at moon. Okay, so by writing this at moon, I'm meaning the gravitational pull of the Earth at the location of the moon. So how does that change things? Well, turning to the universal law, that is g m of the Earth, m of the moon, divided by the distance between their centers. Okay, now that's going to be r E m, meaning the distance from the Earth to the moon, the centers, okay, squared. Now that's a calculable value. It's listed in the cover of the book. Okay, so you can look up that number, the distance between the Earth, the center of the Earth, and the moon, or better yet, the radius of the Earth, the moon's orbit around the Earth. So we can look that up, but we can see the same process that g of the Earth at the surface of the moon, or sorry, at the moon, not the surface, the g at the moon, so relative to their centers, is a number we can calculate. And because this number is so much bigger than this number, this value here is so much smaller. The numerator is the same, but this becomes much smaller because the distance from the center of the Earth to the center of the moon is far bigger than the radius of the Earth, and we square it. Okay, but it's a value, and I could look it up. I could calculate it by looking up these known values. Well, what about the moon? Okay, now let's suppose I'm standing on the moon. Well, I could say, here's my mass. I'm standing on the surface of the moon, so this is g m, meaning g of the moon. This is caused by the moon, right? It's not the Earth at the moon, but it's caused by the moon. Okay. That's going to be equal universal law of gravity. Now I get this big G, and I get mass of the moon acting on me, which would be just a little m, divided by the radius of the moon squared, because I am a distance, one radius away from the center of the moon. I'm at the surface of the moon. So again, cancel those out, and I get G at the surface of the moon due to the moon is equal to G and those are calculable values. I can look up the radius of the moon. I know this g, and I know the mass of the moon. I can find g at the moon. So this discussion here is super important since we've been so used to writing F equals ma, or Fg equals mg. Now we're expanding our abilities. This was only good, truly, for working on things close to the surface of the Earth. It actually worked decently well, even for some low orbital satellites, because the height of the satellite is not that much different than the radius of the Earth. But once you got far enough out, then it gets appreciably smaller because of that square. So since we're so comfortable with this, we need to now break that up and put it within its own assumptions to make that very specific. But we can still find g and still use this as long as we calculate g appropriately.